confidence intervals for the population proportion. So here we are looking into constructing confidence interval for another population parameter, which is the population proportion. So before this, we are looking into confidence interval for the population mean. So here, population proportion. So it is an interval estimate for the population proportion, which is the P, which can be calculated by adding an allowance for uncertainty to the sample proportion P hat. Recall that the distribution of the sample proportion is approximately normal if the sample size is large, with standard deviation sigma p, which is the standard deviation for the proportion, which is the square root of p 1 minus p divided by n, and we can get this by using sample data. So from the sample data, we are using square root of p hat in bracket 1 minus p hat over n. So to construct the confidence interval for the population proportion, so the pattern of the formula is almost the same. So whereby we have the sample statistic plus minus critical value and also the standard error. So here is going to be the sample statistic will be the sample proportion plus minus this will be the critical value from the normal distribution, and this will be the standard error for the sample proportion. So example random sample of 100 people shows that 25 are left-handed, and you need to construct 95% confidence interval for the true proportion of left-handers. So 95% confidence interval is referring to alpha 5%, 95, 100 minus 95, you get 5% alpha. So the upper tail, this area will be alpha over 2. So alpha over 2, 5% over 2 is going to be 0.025. So this is the value, the critical value from the normal distribution. So whereby z 0.025 is going to be equals to plus minus 1.96. So suppose you have a random sample of 100 people, shows that 25 are left-handed, and you need to form a 95% confidence interval. So you just found that the critical value is 1.96. So you need to replace in the formula, the confidence interval formula, whereby the point estimate or sample statistic, the p hat. So p hat is going to be 25 over 100. So you have 25 left-handed from 100. So the proportion is 25 over 100 plus minus critical value z 0.025, which is 1.96, and the square root of p hat 1 minus p hat over n. So this is the standard error, and you calculate everything, you get p, which is between 0.1651 and 0.3349. So how do we interpret this? This means that we are 95% confident that the true percentage of left-handers in the population, or the true population parameter, which is the proportion, is between 16.51% and 33.49%. So suppose from the same example, you want to construct 95% confidence interval for the true proportion of right-handers. So left-handers is 25 out of 100. So for the right-handers, it's going to be 75 out of 100. So the p hat plus minus, this is all the same. So meaning that for the confidence interval for the true proportion of right-handers is going to be the point estimate, which is 0.75 plus minus critical value times the standard error. So you'll have P is 66.51% and 83.49%. So meaning that we are 95% confident that the true percentage of left-handers proportion will lie between 66.5% and 83.49%. for 9%. So we are using the interpretation of percentage for the population proportion.